Hello students, in today's video we are going to discuss the analysis of amphetamine and related compounds. Amphetamines are a powerful stimulator of the central nervous system. It is used to treat some medical conditions like attention deficit hyperactivity disorder, narcolepsy and obesity. But it is also highly addictive with a history of abuse. Amphetamine is used as a recreational drug. People take it to boost libido, increase wakefulness, improve cognitive control, enhance sociability, and induce euphoria. It can also speed up reaction times, increase muscle strength, and reduce fatigue. It is a prescription drug in many countries, and unauthorized possession and distribution of amphetamine are often tightly controlled by the government. Amphetamine belongs to the phenethylamine class. It is also the parent compound of its own structural class. There are a number of amphetamines which are controlled substances, but the most commonly encountered amphetamines in the forensic science laboratories are amphetamine, methylamphetamine, 3,4-methylene dioxyamphetamine, 3,4-methylene dioxymethylamphetamine, and 3,4-methylene dioxyethylamphetamine. The qualitative identification of amphetamine is carried out in three steps. The first step is the sampling and physical description of amphetamines. The second is presumptive testing, and the third is thin layer chromatography. And a wide variety of the types of the sample may be expected by the forensic scientist. And the different types of samples includes powdered drug material, tableted material, and items likely to have traces of the drug samples present. And all these type of samples can be easily identified for the amphetamine by using these three. The number of samples which are obtained for the analysis can be more, and in the first step of amphetamine analysis, all the samples obtained are sorted into number of groups where the members of the groups cannot be distinguished from each other. The atoms in each group should be counted and a good physical description like weight, color, odor and any other physical characteristic is prepared. Similarly, the recommendations proposed by United Nations drug control programs are adopted to examine the number of samples. For example, if there are between 1 to 10 items are there, all of them should be examined. If there are between 10 and 100 items, then 10 random items should be examined. And if there are more than 100 items, the square root of the number of items should be examined. And by selecting the proper number of items, the analysis can be further carried out. If the samples are trace samples, that is, the trace sample is a drug which is likely to be easily contaminated, then the approach should be that the operator, laboratory equipment, and the reagents to be used should be free from drug residues prior to the commencement of the analysis. And this can be achieved by washing the glassware, work surfaces, and operator's hands with a small amount of methanol and concentrating the dissolved materials. The same batch of the solvent should be used for this procedure and for the analysis of the drug items themselves. The items to be examined should then be individually swabbed by using clean swab soaked in a suitable solvent, and it can be easily controlled to subsequent analytical procedures. Once the sampling is done, the number of sample has been decided, it is fixed, the number of samples to be analyzed has been sorted and selected randomly. The presumptive testing is performed. The one of the tests which is generally used for the identification of the amphetamine is the Marquis test. In this, a small amount of Marquis reagent is added to the sample along with the positive and the negative control. The Marquis test includes two reagents. The first reagent is concentrated sulfuric acid and the second reagent is 8 to 10 drops of 37% formaldehyde in 10 ml of glacial acetic acid. 1 to 2 milligram or 1 to 2 drops of the sample are taken in a spot plate and 1 drop of reagent 1 and 1 drop of reagent 2 is added and the color is noted. If we get orange to brown color in the spot plate, it indicates the presence of either N-diethyl amphetamine or methamphetamine. Once the type of amphetamine is identified in the presumptive test, it can be further confirmed by performing thin layer chromatography. And in order that the sample can be tested for the presence of an amphetamine, a test solution must be prepared. The test solution is prepared with a sample concentration of the order of 10 milligram per ml, and the solution or the sample solution is generally prepared in methanol. The sample should be dissolved as fully as possible and centrifuged or filtered to remove any solid particulates. A positive and the negative control should also. The silica gel chromatographic plate will be marked and the test solution, the positive and the negative control are spotted on the plate and it is allowed to develop in a suitable solvent system. Two types of solvent systems are generally utilized in the identification of amphetamine by TLC. The first solvent system is a mixture of methanol, acetone and ammonia, and the second solvent system is a mixture of chloroform and methanol. Each amphetamine gives a different RF value based on the type of solvent which is used. And when the plate is sprayed with the reagent 0.5% fast black B, each amphetamine produces a different color. So the identification of the amphetamine and the confirmation of a particular member of the amphetamine class can be identified based on its RF value and based on the color formation after spraying. Once the plate is developed, it is removed from the solvent chamber, dried at room temperature, and then examined under a white light, short wavelength, a long wavelength, and after spraying with a developing reagent. The commonly used developing reagent is 0.5% fast black B, which is prepared in water. And this amphetamine produces a purple color, while methyl amphetamine gives an orange or red color. In addition to these, MDA, MDMA, and MDEA gives rise to purple, orange red, and orange red color respectively on the TLC plate. Once the spots are visualized, at each of the visualization state, the retardation factor or the RF value of the visualized compound should be calculated and it should be matched with the standard compounds. The RF values of unknowns are compared to those of the standards, and if the data cannot be discriminated, then a suggested match is called. After confirmation of the type of amphetamine present in the sample by using TLC, it is further identified by using gas chromatography mass spectrometry. And this GCMS is the preferred method for the identification of the amphetamines. As the amphetamines are highly polar in nature, so these compounds will be liable to poor chromatographic behavior, and highly polar nature of the amino group results in the sorption of amphetamine to the surfaces of GC system. The components which result tailing if the analytical instrument is not thoroughly clean. In order to solve this tailing problem, a derivatization can be employed, and one of the easiest processes is to derivatize amphetamine derivatives directly with the carbon disulfide. For bulk and trace sample, this is generally achieved by dissolving the material in the swab or approximately 2 milligram of the specimen in zero point 0.1 ml ammoniacal methanol and adding zero point 0.2 ml of carbon disulfide to the mixture. The mixture is thoroughly shaken and then it is allowed to stand at room temperature for at least 30 minutes. The methanol is evaporated to dryness under the stream of nitrogen and the mixture is resuspended in methanol. An appropriate internal standard is added. A positive and a negative control should also be prepared by this derivatization method. The mixtures can be then be chromatographed in the order: the first negative control, then the blank positive control, blank, then sample will be injected in the gas chromatograph instrument. This is the basic requirement for a gas chromatographic instrument which is used for the analysis of amphetamine. The column which is used is of BP5 type, which is 25 meter in length and 0.22 millimeter inner diameter. The injection temperature is 280 degrees Celsius. The column oven temperature is 100 degrees Celsius for 1 minute, which is increased to 240 degrees Celsius at 12 degrees Celsius per minute, which is held for 5 minutes. The carrier gas which is used for the analysis is helium at a flow rate of 1 ml per minute. This is the typical data which is obtained for the analysis of the amphetamine from the street samples. The first two spectra A and B are the gas chromatogram spectra, and the C and D is the mass analysis spectra. In A, the spectra is of the standard amphetamine, and B is the sample which is obtained from the streets. So in this spectra, we can see the amphetamine can be identified based on its retention time. The extra peak in B spectra is due to the caffeine, which is added as an adulterant in the street sample. Similarly, from the mass spectra, also the amphetamine can be obtained by identified by the principal peak, which is obtained as 119 m by z ratio. Once the spectra for gas chromatogram and the mass spectra is obtained for the sample and the standard, the compound can be identified. Similarly, the GCMS method has the advantage that the most common adulterant of the amphetamine, which is caffeine, can also be identified in this system and a suitable mass spectrum is obtained. As with all the drug identification approaches, if the retention time of data and the mass spectra of the compound as well as the standard matches, then an identification can be concluded. After confirmation of the particular amphetamine derivative in the sample, it can further be quantified by using a suitable analytical technique, and its exact quantity present in the street sample can be calculated. Please follow the link in the description box for the detailed quantitative analysis of amphetamines, comparison of the samples, and the detailed notes as well as the question bank of these amphetamine and the related substances. Thank you.